Kia ora koutou katoa, it's Mrs. Goodson here, and this video is number 7, and it's about processing the data that we collect from a science investigation, and in particular for a chemistry investigation, and the one that we're looking at is rates of reaction. So first of all, looking at the numbers that you collect, you will have to round them, especially if you're taking the averages. Just a reminder about rounding. If the next number is a 1, 2, 3, or 4, you round down. So 4.47 becomes a 4. So we're looking at the next number. So we're looking to round to no decimal places in this case. So we're looking at the 4. So that rounds down and just becomes 4. If the next number is 5, 6, 7, 8, or 9, for in this example, we've got 4.8. So then we're going to round the next number up. So this becomes 5, okay? So we're going to round all numbers in a report to the same amount of decimal places. Remember how to take the average, or in maths we call this the mean. So to take the mean or the average, you add all the numbers together. It's important that if you're using a calculator to do this, that you press equals. You divide the number by how many numbers there were. So how many trials? So if you do 3 trials, you're going to add them together, press equals, and divide by 2. If you do just 2 trials, because maybe you're leaving out an outlier, you add them together, divide them by 2. And we usually do 3 trials in science. Now you must convert all measurements to a single unit. So this means that if we've got minutes and seconds, we want to change everything into seconds. Remember, there are 60 seconds in a minute. So if you have 1 minute and 13 seconds, it's going to be 60 here plus 13, so we've got 73 seconds, and that's what the number that we would write in our data table. So if it's 2 minutes and 45 seconds, then that would be 2 times 60 plus 45, it's 165 seconds. Now then once we've got our averages, we're going to do a graph, and in most cases it's a scatter plot or a line graph. But sometimes if you've got categories, for example, small chips versus large chips, you might do a bar graph. But in most cases that we're looking at, we're going to do a line graph, also called a scatter plot. We're looking for a trend. See if we can identify a trend, and that will help us decide whether there is a connection or a relationship between two things. In science, we call those variables. It's important that we label our graph, and that the independent variable is usually on the x-axis and the dependent variable is on the y-axis, and we're just going to plot the averages for our investigation. Make sure you label the axes, you include the units. For example, the temperature of solution A, and then that would be in degrees C, or the time for the cross to disappear, that would be in seconds. So once you've got your dots on your graph and you've got your labels and your title up here, and remember the units, then you'll draw a line of best fit which goes through the middle of the data. Make sure some of the plots are on each side as evenly as possible. It does not need to go through 0, 0. It does not need to go through there. And the closer the dots are to the best fit line, the stronger the correlation and the less experimental error. And just a note, in Excel, this is called a trend line, or if you're doing some sort of spreadsheet package. So you just draw your line of best fit with a ruler, or in some of our experiments, we get a curve. Okay. So this video has been about identifying outlier points and ignoring them. Reminder to do that. Calculating averages, doing rounding, and plotting a scatter plot with a title, even scales, axis labels with units. Units are really important in science, and a best fit line.